The spot info node gives information about the spots evaluated on an object's surface. There's a couple of things that confuse people. First of all, what is a spot? Well, a spot is just a spot. I mean, point your finger out and then, touch down to a point on your desk, that's a spot, and move it somewhere else, there's another spot and another spot and so on. In a manner of speaking, they're infinite. There's an infinite number of little spots all over this surface. But of course they're not being evaluated. You can think of them in certain ways. For instance, when you render the image is made up of pixels. Any pixel that contains a surface can be thought of as a single spot. This is assuming that the surface has been sampled once. And so in a way, you can think of the spots as the samples. There may be an infinite number of spots, but only the ones that are being sampled in some way, or intersecting with a ray or similar, or which are seen at all, are of any interest usually. The other question also comes up, which spot is being evaluated and how do you find them and whatnot? Well, the spots are these arbitrary things. They're not like vertices that have a number and an index and everything else. It's just, if I were to look at this spot, if I were to look at that spot, if I were to look at the other spot, what would I see? And so spot info is giving out information about every spot on the surface at the same time. The simplest way to show this is just to hook it straight up. I've got a ball here with 100% ambience for lighting. If I take the object spot, which is a vector, and so this is essentially the position of any spot I care to look at. I look at a spot, what is its XY position? Plug that into colour, and I get this. The XYZ, 1 to 0, get converted to RGB, 1 to 0, and the ball is shaded thus. Each and every spot receives a colour which is equal to the XYZ position of that spot. And that really is all that there is to what spot info is and what we're getting from it, and how it applies to the object and the surface itself. It is all of the surface. So let's take a look at some of the outputs on it. Object spot, which we just saw, and world spot. World spot is basically the same thing as object spot, but it's in world coordinates. Observe, if I plug in world spot and I rotate the ball, the shading stays put in space. If, however, I plug in the object spot and rotate the ball, then of course the shading is stuck to the surface, because one is being applied in world space and the other in the object's own space. Geometric normal and smooth normal, and normal is just the normal of each point on the surface. Geometric, of course, always gives this faceted look because it is unsmoothed, whereas the smoothed normal is, of course, the result of the smoothing operation in Surface Editor, which of course gives you an unsmoothed surface if it's turned off, even if you're looking at the smooth normal. These normals are all interesting to take note of for one reason. One of the things that they illustrate about how you think in terms of the 3D space from the nodal space. Because what you'll notice with the geometric and smooth normal, you'd expect that that's going to be an object space vector, right? But that's wrong. Look what happens if I rotate the ball. The shading doesn't stick to it. These guys are all world space as well. And if you think about it, it makes perfect sense. Imagine when you've got a character that you're putting a ZBrush displacement on. You use, of course, the smoothed normal, or the normal, whichever. Even though, with your animation on Bones or MDD or whatever else, the mesh might have turned around and moved somewhere else, the normal of any given polygon on that mesh is still being displaced either directly outwards or inwards along its normal. And that normal still has a world vector to it. So even though it might appear on the surface when you're doing something like a ZBrush displacement that's applied on a UV map, you'd expect the normal would of course be an object space normal, but it's not. It's a world space normal that you use to displace. Object space would make a mess of it. So keep that in mind with things like the world and local vectors, the spaces of things. It is important in nodal just as it is in other areas of 3D. Here, for instance, here's something that lets us see how object and world can be exploited, and also how they relate to things we're already familiar with. Let's grab ourselves a vector scalar here, plug the object spot into it, and switch over to its Y channel. Of course, each spot faces out to a certain direction in space. Of course, as we go round this surface, that gets less and less Y in it. So, of course, this scalar is decreasing as we come down the surface here, and going negative as we start to get onto the opposite side of the surface. If we plug it straight into colour, basically what we see is this, the same kind of scalar control that we would have with a gradient using Y coordinate or similar. This little setup we've made is very similar to that. Of course, this is using the object spot, and so it's stuck to our object, just as would be a gradient using the Y coordinate, because that's in the local space of the object. What we don't have the option for with the gradient, however, is the world spot, or the world Y coordinate. At 0, 0, 0, it of course looks the same. But when we rotate the ball, let me just give it a squash to make the rotation that's happening more obvious here. See, when we rotate it, the shading always stays on the top part. We can, of course, also normalize this vector, so as we're only concerned about the amount of space that the object is taking up itself in the world space, which gives us a normalized gradient that always runs from white to black. There was a question on the forums recently where somebody was wanting to be able to populate a terrain and be able to reuse some rock objects but move and rotate them into different positions to break them up and make it a bit more random, and was wanting sand to be on top of each rock via the texture, but of course to always stay on top in a world sense, no matter which way the rock had been rotated and placed. This, of course, is how you would do it. This would let you create an alpha for top, bottom, irrespective of the object space or rotation. So, moving on then, let's see some other common data types. Incidence angle is just the good old incidence angle. Incoming eta is the refraction index, so that only makes sense with refractive surfaces. Then you've got these integers, which are useful in different situations, like bounces. Tells you how many bounces the ray currently hitting the surface has reached. So, of course, ray recursion, radiosity bounce, and so on. Is it a shadow ray? Yes, no. Is it a radiosity ray? Yes, no. Much less used. Polygon side tells us which side of the polygon a given spot is on. That, of course, is for double-sided surfaces. And there we go. Make sure to check out as well, of course, after this, the spot info tutorial on my YouTube set, because that gives some additional information about spot info's usage within networks to create shading effects. And you should also have a look at the nodal thinking one at some point as well, which explains the dot product node, and we see how that reveals the way that spot info works as well. But finally here, before we take off, we're going to do a couple of little tricks. So for that, I'm just going to alter my lighting here. Again, the geometric and smoothed normal. We can use these two guys to get an effect for ourselves that's long been a little bit of a pain in Lightwave. Of course, with some objects, you've got parts of the surface that want smoothing and parts of the surface that don't want smoothing. And you always have to create two different surfaces that are the same, but one with smoothing on and one off. We can actually take care of that using the spot info instead. I've created a weight map here for the areas that I want unsmoothed. I make sure that I have smoothing checked in the surface editor, and then in the nodes for it, I can simply take my weight map, make myself an inverted copy of it, grab a vector multiply node twice over, connect the geometric to one, the smooth to the other, the weight, which is the unsmoothed value, we connect to the same as the geometric, and the inverse of that we connect to the smoothed. We get a vector add node, add the results of these two guys back together, and plug it into our normal. It's all gone wrong, because I forgot to pick the weight map. Unsmooth. There we go. Now we can see that where the unsmooth weight map is, I get unsmooth shading, and where the smooth weight map is, I get smooth shading. So, for those objects where you need to mix smooth and unsmooth surface, rather than creating different surfaces for them, you can just do it in one and use a weight map to define the unsmoothed areas. So I hope that gives you an idea of the information that Spot Info is producing for us and the most useful parts of it and how we can use it to drive certain effects or control different areas.